Hi. Right now, we're just going to introduce you to TinkerCAD for circuits. We've done a little bit of introduction of TinkerCAD to you. You've probably seen it in the modeling section, if you've done that section. So we might have even looked at the code blocks. It's really new. I'm not a huge fan of it, but that's just a me. So let's talk about circuits. Circuits are basic electronics. So TinkerCAD works just like any other proto boarding situation. So if I click on this, I've got some boards I've made before. We'll just pull up a new one, a basic. So I just hit create. I still love the way it names them. If you look up here in the top left-hand corner of my screen next to the waffle of TinkerCAD, you'll see it says a random name every time. You can change the name if you'd like, but you can leave it with what it takes. It does do automatically update saves as it goes, just like a Google Doc. Other than that, the interface is pretty straightforward for this part. This is our rotate tool, our garbage can, or undo, redo. You can literally add annotations. I really don't do much of that. You can hide stuff. We've got our code blocks here for when we get to things like Arduino boards. You also have simulations. You can run the simulation. You can export this out. And then, circuit view. So let's show you what we're looking at. So I'm just going to drag a proto board out here. So I just click on proto board down here on my menu bar, drag it out here. Just like a regular proto board I'd have in my lab. I can even name it. I believe I told you before, mine's called Penelope. Okay, so let's just drop Penelope out there. So there's my proto board. Every time I pop it up, it's going to have the same name on it. I can drag a resistor out here. Now it defaults, I believe, to a 1K. Yep, a 1K resistor. And even color codes it for you. Now, if you look, you've got brown, black, red, and then a gold band. The gold or metallic band is typically the last color bar, and that tells you your tolerance. So this is a brown, black, red. So it's a 1, a 0, and then a multiplier of 100 or 2 zeros. So that comes out to a 1,000 or a 1K ohm resistor. Now, here's what you need to know about this as you're working in electronics. What you find out is this is a proto board, just like you've seen in the classroom, just like you've maybe messed with. All of the positive terminals are connected from top to bottom on each side. All the negative terminals are also connected from top to bottom on each side. That is literally our positive and our ground when we're working. When we bring out a power supply like this 9-volt battery, is 1.5 volt, AA, AAA, DC, whatever it is going to be, or a power supply, that's what it is. The lines, the numbered lines, like 1 through E, 1A through E right here connected, 1F through J are connected, but they're not connected along this way. Now, I like to orient mine like I have it on my board in front of me, so I'll click on the board itself, and I'll rotate it by just simply clicking the rotate button. Now, I will drag a resistor over here and drop it on the board. Now, you'll notice how the terminal ends up automatically defaulting to a row, like this is in 3A and 7A. So if I drop that off, it's connected there and there, so I can actually power this and test it. Let's say I need to take, I'm going to move this over one spot, so I just click on it, move it over one spot. I need to take this to my ground terminal, and I need to take this side of it to my positive terminal. Now, they have to be connected in that row. See how the green circles are around both ends of that? That's important. If they're not, they don't connect. I hate, and this is a pet peeve, I hate to just see all green lines. I like to color them so I can tell what I'm going to. Well, a negative is always a black terminal, and a positive is always a red terminal, just like it is right here. So I put those in, and now I just got to hook a power supply to it. Well, this is going to be exciting. I can't see anything going on in it. Can you actually see a resistor working? No, I can measure it though. So if I come over here to my search bar, and I can actually scroll down the list if I want and get really long, but there's a multimeter right there. I can drag him up and drop him off right here. So I'm actually going to drop 2 of him off. Reason being, certain things got to happen. One, just as in real life, a multimeter doing resistance cannot measure a energized or powered circuit. It's a great way to burn up a multimeter. And if you're using like fluke meters, well, you just paid for a really expensive meter. Just make sure your brain's engaged and you'll be fine. So honestly, I'll have a voltmeter on one and I'll have an ammeter on the other. So I'll literally change that from voltage to amperage. And to do that, I do have to put it in series. So here's the interesting part about meters. Just like in real life, this ammeter, this DMM, I have to connect it so it connects in series to my resistor. So I'm just going to bring that back like that. Again, that is a negative terminal, so I'm going to make it black. And my positive terminal right here has to go over here to this positive terminal here. So I'm going to make sure that lines up, and I'm going to color it red, just like it really is. Now, when I bring a power supply in and hook it to this bus bar, so let's go over here, and I'm just going to type in power. So it gives me a power supply right here. I can drop him off right like so. I will take my red terminal, and I'll bring it right over here and hook it into my red terminal here. That's my positive terminal. Make sure that goes to a red line, and I'll bring my negative terminal or my ground and bring it back to right there. And I will color code that just like the others, but to be black since it's negative. So that's what's gonna happen here is this. I will turn on this power supply just like I would in real life. The current will flow out of this through my circuit right here. Go through this ammeter, then through this resistor, and then back out into this negative bus bar, and then back to my ground right here in my power supply. I have to have a complete circuit or it doesn't work. And just like in real life, I can actually go like this, and I'm going to actually probably connect this in backwards the way I'm looking at it. But you'll see why really fast. I hate to cross lines. That is my negative lead from my voltmeter here, and the positive lead is going to come out just like the other one. And I'm going to hook it in and hook it right here. Now, what's going on in this case is, because this is a voltmeter, see the V, instead of an ammeter, the A, this will measure in parallel the voltage going across or being used up by that resistor. Now, the interesting thing we need to remember right here is this. At no point in this circuit do we have any other resistor, so the entire current and the entire resistive value of this circuit is encased in this one resistor. If I want to get something so I can tell what's really going on, I actually will need to bring in other components, more resistors, etc. But for right now, I'm just going to leave it where it's at so you can see what's going on. It's real simple, direct. So let's go like this, and I'm just going to hit the simulate button right here, but I've never set a power. See, I've never told it voltage. Okay, it defaulted to 5 and 5. Okay, 5 amps of current is very high. I'm going to change that to 1 maximum. I'm going to change this, actually I'm going to change that to 5.5 or 500 milliamps of current, okay? And voltage, I'll let it be at 5 for right now. When I hit the start button right here, I've got 5 volts at 5 milliamps going through this thing, okay? So we're good. But I allowed up to 0.5 amps, which is 500 milliamps. So that means that circuit will power at that point right there. That's all it'll allow through it without burning up, and it kind of acts as a constrictor. So when I stop the simulation, let's say I do something novel here. I bring a resistor over and I put it right here. Now, this I'm going to remove, and this I'm going to remove. You'll see why in a second. I'm going to leave that voltmeter right there, but I'm actually going to change this one over to be a voltmeter as well and do a measurement right here. From that point, I'm going to square that up because, like I said, I have some pet peeves, I know. And this one's going to go right here and connect to the other side of this guy. Now, I do this in class on actual proto boards. I make the students measure them because resistors are never actually what they say they are. Just so you know, that's why there's that tolerance band on it. But I'm going to put those two in there, and then I'm going to bring over another multimeter, and I'm going to put a new ammeter in here. And it's going to measure the amperage going through this. Now, do I need to measure the amperage? No, because I've got an ammeter built in over here. But we'll need him in a minute. So I'm going to leave him right like that, and then just take this guy right here and connect him over here to this bus bar and do that. Now, what's going to happen when I hit the power? Well, let's find out. Start simulation. I've got 2.5 volts in each of those. 5 volts total, 2.5 in each. These are both 1K ohm resistors. That means each of them is taking up the voltage going through the circuit. That's Kirchhoff's law in a nutshell that you've probably read about. You need to understand when you start wiring, because otherwise you'll burn a few things up. So we'll talk about it. Make sure you've read up on that. Kirchhoff's law is kind of important. So is Ohm's law and Watt's law, but that's where we're at with it. So this is how we prototype. We literally do it here. You can't burn anything up. You don't have smoky stuff in the lab. Let's go back here to this. As you get going farther in this thing, you can actually create some interesting things. Like here's a simple circuit. If I hit the tinker this on this one, I have a scope on this as well as my power supplies. So when I tell this thing to start the simulation, it is picking up through those two oscilloscopes I've got attached, two different things. This one on the left is picking up the time constant charge and discharge of this capacitor. This one over here is picking up the flashing rate of this LED. What's happening is it's measuring in milliseconds how many volts per division and how many milliseconds or how many seconds per division horizontally this thing is flashing. So that's all this really does. You can watch the voltage jump up and down depending on whether this diode right here is charged or discharged, and whether this capacitor is charged or discharged. In all honesty, I always laugh because students always want to mess around with things like this. There it goes. It was being a pain. This resistive knob right here, this is actually a potentiometer. I change it, nothing happens really in this. And just because of what it is, it's just a pass through at this point. So we're going to stop the simulation. That's one of the things you can do. The other important thing you can do right here is, I'm going to go over to this guy. And I really like to use Arduino boards on here because you can mess with the Arduino board and actually get something working. Where's the good ones? Let's pick something like this one right here is actually a pretty easy one to show you what's going on. When wired up correctly, you can proto board it out, and then you can actually go build it on your own Arduino board. You actually have to put in the code. Okay, this is a pretty simple code right there. But I will drag and drop it, and I'll just turn it on. So what happens is this: as I turn this knob, I turn that servo right there. So this would give me, like, literally I could hook this knob to a door frame. I can prototype it out and simulate this in real life. So if I was controlling like gates for a flood canal or something, I need to control it. I could take this graduated potentiometer right here and see exactly how much I'm opening that gate or closing that gate, depending on how far I turn that. Now, if you watch, that turns almost 180 degrees. Well, that would be fully open or fully closed. This one, there's a problem. I can simulate my circuit and find out where my problems fall. This one's not working. Why is it not working? Well, somebody's not connected. So I'd actually be able to go back through, check all my wires, all my coding, figure out what's going on. That's what we do with our TinkerCAD, and then you can rebuild it in reality and prototype it out and see how it really works and physically test it, because the computer doesn't understand wear and tear, and this makes it really easy. Thank you for your time. Have some fun with your TinkerCAD and your circuits, and we'll see you later.